I promise to not spend too much time in PowerPoint. I do have some slides, but I'm going to spend a fair amount of time in this presentation, which is addressing cloud security with Open Policy Agent, actually looking at Open Policy Agent, telling you more about it, showing you use cases, showing you code. Okay, so this seems like the right crowd for that. I hope so. All right, a little bit of an overview of misconfiguration risk. We're going to go through, we're going to talk about policy as code. Really, we feel it's mandatory for security and compliance in the cloud, particularly around cloud infrastructure. I will introduce you to Open Policy Agent. You're not going to leave here being experts, but hopefully you'll get a pretty good sense of what it is, what it's good for, how to use it, and what it's capable of. We'll do that through a technical deep dive. And some getting started with policy, and then some Q&A. Okay, so why am I talking about cloud misconfiguration when this is about policy as code? Because this is the domain in which we employ Open Policy Agent at Fugue. We operate at very large scale using Open Policy Agent to check for dangerous configurations and things like Terraform, or even if you go in the console and configure cloud infrastructure, we can check pre and post deployment. So our focus is really around cloud misconfigurations. I've got my dog back here. Hopefully, if you hear anything loud that sounds like a big dog, that's him. Not all right. So, but many cloud misconfigurations, and by the way, these are the most dangerous attack surfaces in cloud computing. Most of the major breaches, if not all the major breaches I've ever read about, and that's kind of my job, are due to misconfiguration of cloud resources, leaving cracks in the wall, if you will. But many times things like NIST and CIS aren't really capturing all these potential misconfigurations. And that means it's really easy to miss them. Now, we support NIST and CIS and GDPR and HIPAA and all that stuff, but we also need to write our own, okay? To catch the real attack surfaces, the real hacks hackers are using out there, we need to write our own. So in many organizations, these things are missed. They're just not known to exist because there's nothing to check against. And this is where policy as code is super powerful. And therefore, they're very common in enterprise cloud environments. All right, every year or so, we do a big survey of the industry, not about our product, but about cloud misconfiguration risk. And I think this year we did about 300 organizations operating at scale on the cloud. That's where these statistics come from. So 84% responded that they were concerned they've been hacked and don't know about it. That's good that many people are concerned about it, because this does happen a lot. A lot of cloud breaches don't get caught by things like traditional data center security technologies, firewalls, IDSs, stuff like that, because they're not going through, many of them are not going through the TCP/IP network boundaries. They're doing things like using IAM and cloud native APIs. 92% are concerned they're vulnerable to a cloud breach. I suspect the other 8% are either not using cloud, but if they are in this survey, they should be, or are getting hacked. All right, misconfiguration risk will increase or stay the same. 76% said it would. I can tell you it grows every time a new cloud API is introduced. You have new potential to not get things right from a security perspective. So it is by definition growing all the time. So Dave Linthicum says here he's seeing a lot of cloud misconfiguration errors in the real world, and it's scaring him. Join the club. Yeah, so I want to talk a little bit about hacker strategy. So this is all background for when I start showing you policy as code and how powerful it is, why, and what you're trying to prevent and what you should be caring about, because prevention is really kind of the only antidote rather to these sorts of attacks, okay? I did a presentation yesterday where I break into my own cloud account and steal all the data out. I'll be doing it at Interop again next week. And in that presentation, I can steal all of S3 data for a customer in minutes. So you really have to prevent. After the fact isn't good enough. So I'm going to start down at the bottom. Skilled or well-funded hacker groups are employing automation to discover and exploit misconfigured cloud assets within hours of their deployment. That's not quite true. It's usually minutes. It's about 7 minutes on average, according to a friend of mine who just works on doing these kinds of research. So whether it's minutes or hours, it's not long. If you put something in the cloud, bad guys are going to find it. If it's misconfigured, they're going to know it. And that gets to these two strategies up here. So the one I'm talking about now is this cloud era exploitation strategy where the hackers are running automation looking for any public facing stuff. They might be going from DNS records. They might just be traversing, IP ranges, whatever it is. They have scripts out there hitting things, looking for misconfigurations. And then they'll go on a shopping from the list of vulnerabilities they find. And that's as opposed to, and this says pre-cloud hacking strategy, it still happens. Right, where a specific target is attacked for specific reasons. So North Korea attacking Sony with a spear phishing attack because they didn't like a movie that Sony made, or Stuxnet on the Iranian nuclear program. Right, these things happen, but far more common is the automation version of this, and that means you have to automate prevention. Because you're not fast enough to keep up with what the hackers are actually doing out there. Nor am I, no one is. Humans are not fast enough. Okay, so policy as code takes takes a different approach to doing security than we've maybe done in the past. It's a better approach. It's at least together a complementary approach that's very, very powerful. In the old world of security was kind of largely a function of operations and security teams, right? They would monitor things and have PCAPs set up and layered defense around the TCP/IP network. As I just explained, most of these breaches aren't really going through much of, if any, of the TCP/IP network on the cloud, and therefore prevention is really needed. And the way to do that is to integrate it into your development process. So policy as code is a way to give developers feedback about security in the same way you already get feedback about things like program correctness, okay? So in traditional general purpose programming languages, you're expressing logical functions and you're operating on data, right? So the programming language, the compiler, the interpreter, the debugger, the tool set around it is going to give you feedback as to whether or not that code is functionally correct. If I try to multiply a string by a floating point value, my language compiler is probably going to complain at me, okay? So that's the kind of feedback I'm talking about. Automated, instantaneous, powerful feedback that's immediate. So with policy as code, it's kind of similar, but we're trying to do a different thing with policy as code. This is how you can express your security posture. With Open Policy Agent, what we're talking about is a query language, not a general purpose programming language. It's based on data log, but it is a language. It is a true language with real language features in which you can express your security posture. And then the evaluation of that code gives you feedback about whether the choices you're making in your cloud infrastructure, in this case, are correct regarding security. So instead of a security team needing to do an audit at the end, I mean, they probably still will, but instead of that being something you're dependent upon, in your development process, if you're writing Terraform code or if you're working in the AWS console, you can check all along the way with instantaneous feedback as to your security posture. Okay, let's get into Open Policy Agent itself. Open Policy Agent is sponsored by the Cloud Native Computing Foundation. As CNCF sponsors a lot of stuff, Open Policy Agent, the folks who wrote it call it OPA as opposed to OPA, so I'll use OPA since that's their call. It's getting a ton of traction, and I'll show you some of the organizations besides just us that are using it. It uses a declarative policy language called Rego. Don't know where Rego came from. And it can validate any JSON data structure. And what that means is you can adapt it or adopt it for a wide variety of use cases. So I'm going to show you, cloud infrastructure use cases today. Probably the most common use case for OPA is Kubernetes transactions on the wire. Very different use case. There's a pretty good and robust tooling ecosystem now. We contribute to that a lot at Fugue. I will show you a couple of our open source projects that can help you with Open Policy Agent and cloud security. Oh. Yeah, I'm not going to spend too much time on this screen. We think having an open Policy Agent as an open source CNCF project is just better than proprietary policy languages. Proprietary policy languages tend to come embedded in products and tend to be kind of half-baked versions of SQL or something similar, or giant XML schemas that make you hate life. OPA is, you can use it wherever. It's open source, and it's useful across domains. And that's really important if you want to skill up on it. Is that a valuable skill? Well, OPA is really taking off, and again, across different domains. So we believe at Fugue that Open Policy Agent is really the first time the industry has had a reasonable and good policy language that is kind of general purpose. All right, just checking time here. I'm still really good. I might even be going a little fast. All right, so there is a myth out there that you need to be doing infrastructure as code to do policy as code. This is not true. And in fact, you can only catch maybe half of the problems in cloud infrastructure by checking infrastructure as code. So it's good to do. I'm going to show you an open source project that we maintain that you can go out and use right now to pre-flight Terraform stuff before it gets deployed. But you can also use the same OPA code, the same Rego programs, queries, I guess, against production infrastructure because the cloud has APIs. So no matter how you've built your cloud infrastructure, I'll also show you a free SaaS we offer for doing just this. The same policy as code that you use to check pre-deployment if you're doing Terraform or something like this, you can use those same policies to check the deployed state. And that's usually actually the better place to start because very few organizations are 100% infrastructure as code. And even those who are, it's only as good as the day it was deployed usually because these are mutable. So don't think that you can't use policy as code and Open Policy Agent if you're not using infrastructure as code. You can, and you can do it very, very easily. All right. So you need policy as code because of the disparate methods to create and modify cloud-based systems impact your security posture. Put another way, I was just referring to this. You might have some stuff going in infrastructure as code. You might have some stuff from maintenance Windows or old infrastructure you've been running before you adopted infrastructure as code that are changing those cloud environments. So we believe it's really important to run policy as code, not just in the early stage of the software development lifecycle, although you should do that, but also to use it as a way to monitor the ongoing state of your infrastructure. Yeah, so from design time, you can do validation of infrastructure as code with policy. To deploy time, you can integrate into a CI/CD pipeline such that if your infrastructure as code changes would introduce mistakes, the security errors, vulnerabilities, you can have the CI/CD toolchain stop that from happening by getting that feedback from Open Policy Agent. And then you can also use policy as code to do enforcement. So you've used it at design time, you catch about half the stuff or so, you've checked on deploy and it passes, you go into production, and then you can constantly reassert that policy to make sure that the infrastructure doesn't drift out of conformance. And this gets extremely important as you scale on cloud. So we run billions of policy evaluations a day at Fugue for our customers. And what we see is, customers with tens of thousands of cloud resources or more across hundreds of accounts. that's where the enforcement becomes super important, because you're accumulating stuff. And it is impractical to do absolutely everything through infrastructure as code. One, you're not going to catch everything in infrastructure as code because of the side effects of the APIs. Two, and three, you just sleep a lot better at night if you have an actual current understanding of your security posture. So policy as code helps with all of these. OPA helps with all of these. All right, I'm going to dig in for a few minutes here, and I'm just going to go to a web browser and go to Open Policy Agent. It's openpolicyagent.org. There's a couple things I want to show you on this page. And we'll get into code samples and a little deeper dive too. I'm not going to use their code samples because it's inconvenient here. But what I want to start with is, kind of what is this thing as a runtime? So there are two ways that you can run Open Policy Agent. One is as a daemon, and the other is as a library. And this is really important, because depending on your use case, you might want a OPA service sitting out there in your application as a microservice, or I don't know, is every service a microservice now? I don't think databases are micro. But you might have it running as a daemon to be called via a service mesh, or just, a web endpoint. And that works well for many scenarios. In our case, we're running so much of this that we use it as a library. We can't afford the network latencies. So we're actually attaching that library directly to our running program in Go. All right, it is written in Go. They have some stuff about tooling and so on. The VS Code plugin for this is really good. I'm going to show you that in a minute. But let's go jump over briefly to their GitHub. So here's their repo. You can just go up here and download it. I'm going to show you some other open source tools that we've written that can help you with this. But let's take a look at the adopters list here, just to give you an idea of how much traction this thing is getting. Oops. I'm struggling with Zoom here. I'm fighting Zoom windows. So Atlassian, BNY Mellon, Capital One, Chef, Cloudflare, Control Plane, Fugue. We were a very, very early adopter of Open Policy Agent. Goldman Sachs, Intuit, Netflix, Pinterest, SAP, T-Mobile. So you get the point. A lot of folks are using this now. And this is I've been in the security software. I'm a software architect and a programmer. Well, now I'm a CTO, but that's my background. I'm not a security engineer who sits there watching consoles. I make stuff. It's the first time, and I've been doing that professionally since the early 90s. It's the first time there has been a really good policy language and runtime that is generally available and can be used for most use cases. And I think that's due to a number of things. One, the proliferation of JSON. Right now we have typically a pretty uniform data structure we can operate against. And service architectures in the cloud have allowed this to happen. So, but it's here now, which is awesome, because in the old days, it was always, you had to learn how to do policy once, twice, 3, 4, 5 times. So just a little more about the language before I jump over to showing it to you. So it is just right here. It is a declarative language. So if you've written in declarative languages, you know what this means, but in a nutshell, it means you're describing nouns more than verbs. you're asserting things rather than saying creating for loops or things like this that are process control. So it's a declarative language. It is high level, which means it's readable and powerful. It's actually very powerful. It's based on Datalog, which is kind of alternative to SQL in a way. It's a query language. It's a language for operating on data and understanding data. And this is another key benefit of OPA over earlier approaches to this, okay? In the past, policies have usually been expressed, and I know like there are proprietary products in, even in the cloud service providers, those policy languages that are embedded in AWS and Azure, they're not languages, they're configurations at best. So what you can have with a real language are things like comments and breakpoints. If you do that, you can program with them. So it's a declarative language. It's a easy to use language. I will show you some really simple examples. It's also a very powerful language. So one of our criteria when we were looking at it, my personal opinion of languages, and I've written in tons of them, is two things I look for among many. One, it should be really, really easy to do easy stuff. And two, so hello world shouldn't be 20 lines of code. And two, it should be possible to do anything in the domain elegantly. And OPA and Rego really meet those criteria. Obviously needs to go fast. I'll show you an open source project we wrote to make it like 30 times faster because we needed to go really, really fast. Okay, let's look at a couple of open source projects that we've put together. So I'm kind of bouncing back and forth between talking about OPA itself and the domain of cloud security. So Regula, and you can get it at github.com/fugue/Regula, is a way to use OPA policies to check Terraform prior to deployment. Okay, and you can see here, we're getting a fair amount of traction out of it. Got hundreds of stars now, a bunch of forks. The way it works is when you are using Terraform, there is a step in Terraform called the plan stage. And this is where Terraform kind of expresses in an interstitial format. You can ask Terraform for this. So you've got your infrastructure as code, which is vague, honestly. It hides all kinds of things behind statements that you really need to understand what's going to happen. Like when you build a VPC network, you get a default security group with open egress to internet. That's probably bad. Well, in your infrastructure as code, you're probably just saying you want a VPC network. But when you see the outcome of what the API calls are going to be, you can then know, oh, by the way, this one's going to get a dangerous security group. So the way Regula works is you just run Terraform as normal. You hook Regula up to it. It's really a bunch of Rego. So you can see all these policies, things like, over here, let me switch to a code editor. So this is just my Visual Studio Code. So here is a simple policy that says for KMS keys, allow if enable key rotation is set to true. All right, so this is really your declarative block. All right. So, and I'll come back to this, but Regula has a bunch of these built in for AWS, GCP, Azure, and the way it's going to work is you can just inline it into what you're doing. Bin Regula, it's shell scripts and OPA code, and it's going to call Terraform, it's going to generate a plan, and it's going to allow you to check against that plan. You can do stuff like custom error messages. So if you're using Terraform, this is open source, obviously free forever. There's a GitHub action for it. If you don't want to install it, you can just call our GitHub action. And it's a way for you to check your Terraform templates prior to deployment, okay? And I'll dig more into the OPA code itself momentarily, but I want to show you how, so this is, back to my slides there, this is this design step, right? And into deploy, right? But what if I want to keep going? Well, I can't show you an open source project that does that, but I can show you a free product, free forever product that we make called Fugue. The developer edition is free. And this is an automated diagram that we generate of your infrastructure when we look at your infrastructure. I'm not making this a product pitch. I just need to show you how you can use OPA in production. You could write your own, but we're the only ones doing this at present. So, and you can see here, I've got a VPC network with an internet gateway, a load balancer, some EC2 instances, And a bunch of this stuff has been lit red. And the reason for that is it's failing the OPA policy checks that we're running behind the scenes, okay? We have big libraries of these baked into the product. You can also, if you're writing your own to use with Regula, you can load those same ones into Fugue as custom rules and get that same feedback. So here we're doing this, daily or hourly. So you can really go all the way through the life cycle using OPA today for free really, really quickly. All right, let's go back to talking about Rego itself. I'm just going to use this really simple example because there's a number of language features here that are notable. It's a real language, as I said before, and so you get some real language goodness. Note the lack of curly braces or angle brackets around everything, and no deep nesting of curly braces to count your indentations. I hate writing code in XML, JSON, or YAML. It feels like we're just taking a huge step backwards. So this is a real language. We start with a package declaration. So it's just, we're naming this as a package. That means we can refer to it elsewhere, just like in any other language. Here, we're just defining some variables, right? And in this case, we're saying the resource type equals this string, AWS KMS key. This is going to map to the data structure. Okay, I can't get into like spelunking the whole data structure today, but I just want to give you a feel for how this works. But this is much like any other code you'd write, right? You're declaring a package at the top. You're defining a couple of variables here. There's just a single one, and controls is a list of strings, right? So we got our curly braces, CIS28, and of course we have our own Regula numbering scheme. By the way, the Regula rules we've put out cover most of CIS benchmark that can be covered at the Terraform plan stage. So you'll get a bunch of CIS stuff right there for free. All right, this next one is where declarative languages might feel a little bit different. It's actually not an unusual thing if you just think through it logically. So we're saying, so what you're doing with OPA, with Rego programs, queries, is you're trying to get back a thumbs up or a thumbs down. Did this pass? Did it not pass? And if it doesn't pass, what should I say about that, right? What error should I return to give that programmer feedback to go fix the problem, right? And you saw some of those right here. So these things are failures. This message, ELB listener source protocol should not be set to HTTP. You should use an encrypted protocol. That's the error message coming back from the OPA evaluation as policy as code. In this case, we're doing it by examining the infrastructure, generating a data structure from that, and then comparing it to the OPA rules, which is the most complete way. Over here in Regula, we're doing this at the Terraform plan stage, but that's what the error message allow and deny are about. So by default, we're saying don't allow. By default, we're saying deny. So default allow is false. So allow equals false equals deny. Does that make sense? A non-allowance is a denial. Okay, so we're setting the default to false. So and this is a really good way to start most of your policies, because then you're only allowing the exceptions to that. So you're going to deny everything unless you set it to allow. And you'll see things like AWS policy has a default deny to all permissions, and there's a very good reason for that. So does when we use OPA, that's how we use it. A little coffee there. All right, so then, but we can say, but that was the default, but allow, right? We don't have like a logic block around this. We're just saying allow. And this is the condition that turns that false to a true. So in this case, it's the input enable key rotation is equal to the value true. Okay, like a lot of languages, equal is you know, the checking for equivalence, not assignment. All right, I'm going to go into. I told you to do easy stuff should be easy. I think this is really easy. I hope you agree with me. If you don't, you don't. All right, let's try to find a bigger one. Okay, here we go. But I also said you should be able to do very sophisticated things as well, right? So here, and we've written a lot of Rego for you and a lot of utility stuff in Regula, so you don't have to mess around with it. But I'm just going to show you a fairly complex policy here. So here, the last one we looked at, the resource type was a KMS key. Here we're just saying multiple. Okay, that tells our libraries what to do that we've written in Rego. And by the way, we've written all of this in Rego. There's no like Go program behind it other than the language interpreter that you know we're defining these things in. It's all written in Rego because it's a real language. You can do real projects in it. Okay, so we've said multiple, which is a keyword for our libraries to say, oh, they're going to be referring to multiple kinds of AWS services. So here we've got some comments. Also nice to have comments. I'm going to get rid of my file browser here so we get a little more width. I always forget the command for word wrap. Oh well. And here we're starting to define some things. So we're saying policies of name equal P, IAM policies equal fugue.resources. That's one of our libraries, stuff that says AWS IAM policy. But that's not the only place you can find these policies, right? You also have to look at IAM group policies, IAM role policies, and IAM user policies. So here, we're collecting these up into policies, and then we're doing some checks on them, okay? So don't worry about this one. You probably don't need to write anything near this complex. I pulled out a hard one just to show you a hard one, to show you can do sophisticated things. Here's a kind of medium one. So here we're saying that an AWS S3 bucket, what are we doing here? Yeah, server-side encryption. So we're looking for server-side encryption on that S3 bucket. And you can see here we're counting up the used SSE algorithms minus the SSE, valid SSE algorithms. We're counting those up to create an allowance if true, which means greater than 0. All right, so let's look at some of our library code here just briefly. We've done a lot of work for you. This is all in Regula. This allows you to not have to muck around with too much Rego and just write really simple rules like this. And again, those rules can be used both in Regula and locally or through our agent, or you can also load them up into Fugue if you want to use a free SaaS for checking your infrastructure. I want to show you one more project. I'm running low on time here. This is another open source project called Frego, which is the Fugue Rego Toolkit. This is, we needed better developer. We write a lot of Rego, hundreds of these things, you know, we're constantly adding more. And we write very sophisticated Rego. So we needed better tooling than the standard Rego. And we also needed faster evaluation because Fugue is running billions of Rego evaluations a day in the cloud. So we wrote this thing called Frego. It's actually the Fugue Rego toolkit, and it allows things like breakpoints in a REPL. So if you want a REPL that can help you more than the kind of stock one, which you might find a bit mystifying, so you can like check values as you iterate through the program, just like any other REPL that has breakpoints. Yeah, so this is not implemented as a, now we also use Frego as our like runtime evaluation engine because it's super, super fast. And we predominantly use Lambda. And so time is literally money for us. We like to keep our costs, cloud costs really, really low, and they are. And the way we do that, well, relative to, the size of our customer base, the way we do that in part is Frego is just super, super fast, somewhere between 30 and 100 times faster than stock OPA for these large data structures that we're operating on. So you can go and get Frego. VS Code is just a great editor to work with it in because the plugin is so good. Yeah, you can see most of these are simple, right? It's only when you get into really complex data structures because the cloud providers have made them complex, where you start having to write more complex Rega. Well, I think I'm coming up on the top of the hour, so I'm going to go and see if I have any more slides. I hope. Oh man, the font went nuts on this one. All right, so here, these are the getting started resources. One of our partners actually wrote the automated infrastructure compliance framework down at the bottom. It works with Regula and does some cool CI/CD stuff. So I think that kind of wraps me up.